So to start with today, we're going to work on finding a slope from a graph. Okay, finding slope from a graph. Okay, finding slope, excuse me, from a graph. So for example number one, if I, actually I'm going to get some graphs so I don't have to draw them for you guys, so that hopefully you can see them a little bit better. Okay, so you can just do your best to draw them. It's not a huge deal if you don't draw perfect graphs, okay? As long as you can just look at mine, that's fine. Okay, so for example number one, and I'll take this down in just a second. If you have a graph that has a point here and a point here. So we have a point at, what point would this be called? Negative 1, negative 1. Okay, so if you just have a picture and it has two definite points marked on it, okay, there's definitely 2 points marked on it. You want to count from those 2 points. Okay, you don't have to worry about counting from any other points or figuring out exactly where this graph goes through. Okay, so if you have 2 exact points on there, one of them is at negative 1, and the other one is at over 1, 2, 3, up 1, 2, 3. Over 3, up 3. Okay, all you have to do is if you have 2 exact points on there, you're just going to count. Okay, what's the formula for slope? The general formula? Rise over run. Okay, rise over run. Now, automatically, if this was a multiple choice answer or multiple choice question, is this slope positive or negative? If you were walking on this line, would you be going up a hill or down a hill? Up. So that is a positive slope. So automatically, anything that had a negative in it, you should throw away that answer. There's no way it would be negative. Okay, so literally you're going to count how far you go up and how far you go over. So you'd go up 1, 2, 3, 4, up 4, over 1, 2, 3, 4. Up 4 over 4. You should reduce. What does that reduce to be? 1. Slope of 1. That's it. Okay, we're literally just counting the slope. Okay, literally just counting the slope. So you're counting how many steps you take up and how many steps you take over. And remember, we're always counting how far you move to the right. Okay, we're always going up or down first, and then you're going to the right. Okay, let's try another one for number 2. Helpful if my pencil had lead. Number 2. What about if I gave you a graph? Sorry, I should have had these ready for you guys. If I give you a graph and it has a point here and let's go and here. Now, it doesn't even have to be perfect, okay? You don't have to draw these exactly perfect. We just have to know, and you don't even really need to know what these 2 points are, okay? So, rise over run. Does this graph, when you're going from left to right, does this line rise at all? No. No, it's falling, okay? So, rise or fall. So, that means that its numerator, the top number, is going to be what? Positive or negative? Negative. Negative. So you would count. So you'd go down 1, 2, 3, 4, 5 steps. So that's a negative 5. And we would go over 1, 2, 3. Negative 5 over 3. Now, should I change that to a mixed number? No. Okay, we want to leave slopes as long as they're reduced and nothing goes into both 5 and 3. You want to leave those as an improper fraction. Okay, questions on how we did that? Not too bad, right? Okay. Now, what about for this kind, number 3? What happens if I don't give you any points? Okay, if I just give you a line and you have to figure out where it crosses. Okay, what if I just give you a line that looks like this. If I just give you that, and there's no exact points on there. I'm not showing you exactly where it crosses. What kind of slope is that called? I don't remember. Not exactly.
I think I'm like.
What's it called? Parallel is when we have two lines that are exactly in line with each other. Say it again. Vertical, not exactly. Okay.
On the X graph.
That is an x equals graph, okay? Let's think about this. If I was going to walk up, this is like a wall, okay? And this is not about you, it's not about Superman, it's not about Spider-Man, it's about Mrs. Coon. Can Mrs. Coon walk straight up a wall? No. I am not able, okay? So, is it possible to walk up this wall?
No.
No. So what would you call that? What kind of slope is that? What's an impossible slope called? It's called undefined. Okay, undefined. Undefined. Undefined basically means not possible. Okay, that's called an undefined slope. Right. But, and the reason this is undefined, because this is not about Spider-Man or Superman or any other superhuman person. Okay, it's about me. It's about me. Mrs. Coon cannot walk up a wall. Therefore, it is an undefined slope. If you are able to, because you are secretly Spider-Man, good for you. But I can't. Okay? I'm sorry, but today it's about me. That's great. Thanks for sharing. Okay, next one. That's great. And I look forward to not knowing who you are and not realizing that you are Spider-Man. Great. Okay, next one. Let's try another one. Okay, for example, number 4. Okay, again, what if I don't give you exact points? Okay, if I don't give you exact points and I just draw a line. Okay, let's just draw a line like that. If I don't give you exact points, how do you find the slope? Any ideas? It's not undefined. No, because it's not straight up a wall. You have to figure out where it goes over exact points. So, do you think this is an exact point right here at a cross? We have to look for what's called lattice points. Lattice points are where it crosses this is called a lattice behind it. Can anyone tell me where do you think is
right
one
there.
of the lattice points? Do you think this is one of them?
-1, 0.
I'm not so sure about that one. This one is supposed to be one. Where else do you think has another one? You think right here, okay? This should be another one. So, I don't care if you name those points, you just have to be able to count them, okay? So, count rise over run, and it has to be across exact, what are called lattice points. So here, to get from, and we always go from left to right, it's just like reading a book. You'd go up 1, 2, 3, 4, 5, up 5, so that's positive 5, over how many? 2. 1, 2. Rise over run or slope is 5 over 2.
What if we did like instead of putting it on there, you see that one? It's like right there.
This one?
Wait, now go up, go up.
This one?
Yeah. What if we did that one instead?
Well, your lines on your homework are going to be exactly perfect, and so they're not going to be like kind of shaky like mine. So they'll be exactly perfect on your homework, okay? I promise, because it's already printed out for you. They won't be kind of shaky like mine. So I apologize. That one should not have been perfect because that's my bad. Sorry. Okay, let's try another one for number 5. Okay, this will be the last one for this part of notes. Okay, last one for this part of notes. If I give you this line, it looks like this. Can you find 2 exact points that look just like that?
Is that a y equals graph?
It is a y equals graph, yes. So again, we have to pick 2 points. Where are there 2 exact points?
Anywhere.
Lots of places, right? Okay, let's say right here and right here. How much do you rise?
0.
0. Over, how far would you go to get from this point to this point? Over 1, 2, 3? What is 0 over anything? Is it 0 or undefined?
Undefined.
0. Okay, I want you to write a little saying for me. Okay, 0 under is undefined. Okay, 0 under is undefined. Okay, so that means anytime you have something like 3 over 0, if there's a 0 in the denominator, it means undefined. And undefined, you write 0 with a slash through it. That's how you write undefined. I'm getting there, yeah. 0 over, okay, 0 on the top, 0 over is 0. Okay, so anytime you have 0 in the top, it means your answer is 0. If you have 0 underneath the fraction bar, it means your answer is undefined. Do we have questions on how we did that?
No.
No questions on how you did that?